All right, so we're back with the second part for the quadratic equation, and then this part actually popped up from before. So remember when we were doing partial factoring in one of the last videos, and in this partial factoring part we talked about finding this common point, and I believe the point was 10, and so we found 2 points and used those to find the axis of symmetry to graph this thing out. So we couldn't find what these points, what the x-intercepts were at that point, because we didn't quite have the tools to do it. The equation didn't factor nicely. But now, because we understand how the quadratic works, we can actually factor this thing out and find out what those roots are. And so let's take a look and let's see if we can't figure out what we're going to get for those roots. So I have my a value as -1. I have my b value as 6, and I have my c value as 10. And remember, this is when the function is equal to 0, because I'm finding the x-intercepts. And when I find the x-intercepts, my function, or my y-axis, is equal to 0. So if I set up my quadratic equation, and let's move this down a little bit. So if I set up my quadratic equation, and I have x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to, I've got minus b, which is minus 6, plus or minus the square root of b squared, which is 6 squared, minus 4 times a, which is -1, times c, which is 10. 2 over 2a, so over 2 times -1, and then I have my values that I can start to work with. So before I go too much further here, I should note, I guess, or look at this, we should have a rough guess as to what we think this thing is. And so if I look at my graph and look at where I am, each of these lines count by 2's in order to get to the 10 that's there. So that means that this thing looks like it crosses somewhere around 7. The other one looks like it crosses somewhere that's just past -1. And so that's kind of where my guess would be, or my ideas where these roots are going to pass through. And so I should have that in mind as I move forward, because if I get answers that don't match up, then I probably made a mistake somewhere that we can go back and check. So if I'm taking a look at this, now I can keep this kind of simplification step going. So minus 6 plus or minus the square root of 36 plus 40, 4 times 1 times 10, all over -2. So x is equal to -6 plus or minus the square root of 76 over -2. Now in the last one we did some factoring with that root term to see if you could simplify it, and I encourage that you go through that step. So I'm going to try to do some prime factorization here and just break apart 76. So 76 would break apart into 2 times 38. And then 38 can actually break apart into 2 times 19, which tells me that really 4 times 19 is going to give me 76. So that means that root 76 can really break apart into 4 times 19 under the square root, which can really break apart into root 4 times root 19. I know the square root of 4 is 2, and so I can rewrite root 76 as 2 root 19 and simplify this a little bit more. So let's use that idea and keep this going. So x is equal to minus 6 plus or minus 2 root 19 over -2. Between the 6 and the 2 in front of the root 19 and the 2 on the bottom, I have a common factor there of 2, so I'm going to divide everything by 2, and I'm going to simplify this out. So now once I write this out, I've got x is equal to minus 3 plus or minus the square root of 19 all over -1. So I have 2 separate roots that we're going to work out. Same way as we've done before, we've got a plus and a minus root. And so we have 1 as the positive value and 1 as the negative value. So x is equal to -3 plus root 19 over negative 1, which all that means is that the negative 1 is flipping the sign on each of the top roots. So instead of saying negative 3 plus root 19, that negative 1 is just saying really it's plus 3 and minus root 19. So in order to drop the negative on the bottom, we just change the signs of the terms in the numerator spot. So 3 minus root 19, there's 1. Now if I do my bottom one with my subtraction in terms of the plus or minus, I have x is equal to minus 3 minus root 19 all over negative 1. And then applying the same principles here, that means that I really have 3 plus root 19 as my other root. Now we could take a calculator and we could actually check and verify that these, because these are my exact values, but we could take a calculator and kind of verify where they are just to be able to compare to our graph. So if I took 3 subtract root 19 into a calculator and punched in those numbers, my answer is approximately negative 1.358. And if I took a calculator, same thing, and punched in 3 plus the root of 19, then I get a value that's approximately 7.358. And so if I take a look at that compared to my graph, I believe initially I had said that really it looks like negative 1 and 7 as my two roots. And I can see here that I'm getting negative 1 in a little bit and 7 in a little bit. So I'm pretty confident that those are the correct answers for the roots for this function. But again, without knowing the quadratic, I wouldn't have been able to find the roots for this and to go through and to figure out the calculations. So the last part that we have is a little bit of a word problem. It's a little bit of a thinking problem to go through. It says that Ian's been hired to lay a path of uniform width around a rectangular play area using crushed rock. He has enough crushed rock to cover 145 square meters. So if Ian uses all the crushed rock, then how wide will the path be? And so I have this area, this play area that's 24 by 18, and really what we're doing here is we're trying to figure out the area inside of here. Okay, what would the width be all the way around the play area in order for me to have enough stuff to fill it in with 145 square meters. So I need to set up a formula, and then we need to figure out how to solve this thing. So if you think you want to give it a try, pause the video, see if you can come up with an equation to work with it, and then when you come back, we will go over the answer for it. All right, so with this one, we have to kind of keep in mind what it is that we're looking for here. And we're just looking for that little strip around the outside. But that doesn't stop us from kind of figuring out the total area and where we can start. We just have to keep in mind of the middle part not really being needed. So the total area for this, or the area that we're trying to figure out, is really the total area and then we have to subtract from that the play area that's here. Because if I can take that whole chunk of play area out, I'm just going to be left with the area on the outside. So we're going to take away the play area. So the total area is really just length times width. And the play area is also length times width, but we're given those numbers. The play area is 24 by 18. And I believe the values given are in meters for these. So the area of this, now I need to take a look and see what's the length. And it looks like the length of this thing, if I were to calculate it, is 24 meters wide, 18 meters long. So it doesn't matter which one you pick for the length or the width. I'm going to just pick the 24 as my length, and I'm going to pick the 18 as my width. So if I'm taking a look for the whole length of the outside, okay, of this whole part right here, then I know that it's 24 meters, and I'm given that this value is x meters in width, which means I have an x value here, and an x value here. So this thing's really 24 plus 2x for the length. So 24 plus 2x. Now that's being multiplied by the width. And so the width of this thing, same thing now, the width is going all the way here, and I know the width is 18 meters, and then I have 2 extra x's that are there to make it the full length. So it's really 18 plus 2x. And then I'm going to take away from that 24 times 18, which is 432 square meters. So now I'm going to go through and simplify this out. We're going to multiply everything through, so my area that I'm looking for, I have two binomial terms here, so I need to use FOIL to basically figure them out. So my first two terms, 24 times 18, I actually just did that one in the last step, so that's 432, and that's square meters. I have 24 times 2, so that's 48x. Inside terms give me 36x, and my final two terms give me 4x squared. And then after that, I've got this minus 432 meters from before that I just need to carry forward. So right away what I see here is 432 meters and 432 meters are going to cancel each other out. One's positive, one's negative. So the area of this thing can be equal to 4x squared plus 84x. And then the last part is to say, in terms of the question, he has enough crushed rock to cover 145 square meters. So 145 square meters of area has to be enough to fit the width of our problem here. And so if I were to look for a 0 for this, 4x squared plus 84x minus 145 square meters, okay, or my constant, 145 in this case. So when I look at that right away, there's no easy common factor to go through or to figure out, so I really just need to punch it into the quadratic equation and see what I get for an answer. And in this case, it's not looking for the exact answer, so I'm going to get it close, and then I'm just going to take a square root of it to find out what value I'm going to have. So we'll set up our quadratic. Hopefully after a while you'll have this thing memorized. It is x is equal to minus b plus or minus the square root, b squared minus 4ac, all over 2a. So x is equal to, I have a minus and a b term of 84, plus or minus the square root of 84 squared minus 4 times a times c, all over 2 times 4. That gives me negative 84 plus or minus the square root. And then if I do 84 squared, I get 7,056. And it looks like I'm going to be adding these together because I have a minus times a minus. So plus, and then I have 4 times 4 times 145, which gives me 2,320. That's all over 8. So we're almost to the point where we can just simplify and take an approximation here. We just have to add this together. So 7,056 plus 2,320 gives me 9,376. And all that is over 8. Now, these numbers are far too large to go through and to take common factors of a prime factorization to see what I can cancel. So let's just work out this thing as a rough approximation. So minus 84 plus or minus the square root of 9,000 376. Gives me 96.8297. Okay, just gives me a rough idea of what we have for a value. Then what I can do after that is I can start to go through my two separate roots. So really from here, I'm into my plus root and my minus root. And because I'm going to kind of simplify these out a little bit, I'm going to write them on the side this time. Same as I've done before. I've got a plus root and then I've got a minus root. So we know that we're taking the positive value of this. So if I took minus 84, so x is equal to minus 84 plus 96.8297 and divided that all by 8. So minus 84 plus 96.8297. I'm plugging this in, just going through hopefully the same way you guys are, and dividing that value by 8. I'm getting an answer that's 1.6037. And in terms of relative what this is, that's the width of the fence, so it's in meters. If I take a look at the other one, then x would equal negative 84 minus 96.8297 all over 8. So x is equal to, and again, I'm just going to go through and plug this in just kind of the same way. Hopefully you guys did too. 96.8297 and divided by 8, and I'm getting a value that's negative 22.6037. So the problem that we run into with the bottom one, when we figure out an answer for it, really is that I get that negative, and I can't have a negative width. It doesn't fit in the context of the problem. So this answer is in fact a root. If I were to graph this thing out, I could definitely see that I'd have a value over here at negative 22 and 1 at 1. And so if I took my my equation, I could really see that this thing opens upward, and so it would kind of do something like this, right, and go through. But really what I'm looking for in this case isn't so much what it can do with that. I'm looking for what that maximum width could be. And so this one isn't going to help me relative to this question. This guy's called an extraneous root. And so in terms of the question, it doesn't make sense. It's eliminated. And so what's my actual root? What's the one I'm looking for in my answer? It's 1.6 meters for a fence for width. So this is the one that it's looking for in the question. So I determine the width of the path that will result in an area of 145 square meters. It is 1.6 meters for a value. So hopefully that gave you a bit of an idea on how these things are solved, how they work. We have kind of our key idea here, the roots of the quadratic equation in the form ax squared plus bx plus c equals 0, where a can't be equal to 0. And it can be determined by using the quadratic formula, where I've got my quadratic setuplets there. And so there's some need to know stuff here. Maybe it's something that you want to jot down in terms of notes. The quadratic formula can be used to solve any quadratic equation, even if the equation is not factorable. And that's kind of the big advantage to it. If the radicand in the quadratic formula simplifies to a perfect square, then we can actually just solve it through factoring, and we've done that. If the radicand in the quadratic formula simplifies to a negative number, then basically that means that there's no real solution to the quadratic. And what this means when it says radicand is this part right here. So if I take this value and I get a negative number in there, then that means that there's no real roots for it. Because if I get a negative and you try to take a negative in your calculator of a square root, you're just going to get an error. And so that means that there's no solutions. So that wraps up the unit on quadratics. Once you kind of get a handle on this, let me know if you have any questions, and we'll practice some problems later.